Hello student, this is me, Sudhanshu Singh, your chemistry faculty. I welcome you all to Online Padhega India. In previous video, we have discussed what is solid and what are its important characteristics. Okay. In today's video, I am going to discuss classification of solid. Okay. So let's get started. Okay, this classification of solid is based on arrangement of constituent particles. That is, how constituent particles are arranged in solid. This is a very important. Okay, on the basis of arrangement of constituent particles, solids are classified into three categories: amorphous solid, crystalline solid, and polycrystalline solid. Polycrystalline solid is not in your syllabus, that's why I am not going to discuss it. Okay. Now look at diamond and glass. Okay, both are solid. Okay, now look at microscopic level. What you see? You see that at microscopic level, diamonds have definite arrangement, whereas glass have irregular arrangement. Okay. Now let's move to definition of crystalline solid and amorphous solid. What is amorphous solid? At first, let us understand crystalline solid. Okay, then we will discuss amorphous solid. What is crystalline solid? It is a type of solid in which constituent particles are arranged in an orderly fashion. That is, they follow definite regular pattern. Okay, examples are gold, salt, metal, etc. Okay, now let's move to amorphous solid. Okay, amorphous word originates from a Latin word morphous. What do you mean by morphous? Morphous means with a proper shape, whereas amorphous means without a proper shape. Okay, now let's define what is amorphous. It is also a type of solid in which constituent particles are not arranged in a regular fashion. That is, they don't follow any regular pattern. Okay, now we will discuss what are the major difference between crystalline solid and amorphous solid. Look at this table. Okay, we are going to discuss difference between crystalline solid and amorphous solid. Okay, at first let's understand shape. Okay, crystalline solid form a definite geometrical shape. Okay, why crystalline solid form definite geometrical shape? Because it has regular pattern of constituent particles, whereas amorphous solid form irregular shape. Why this is so? Because they don't have regular pattern. Okay, now discuss melting point. Okay, crystalline solid have a definite melting point. That is, they melts at a certain temperature, at a particular temperature. Okay, suppose A is crystalline solid. Okay, and its melting point is 100 degrees Celsius. Then if heat is supplied to A, then it will not melt below 100 degree, and it will melt at once when temperature is reached 100 degrees Celsius. Okay, whereas in case of amorphous solid, it doesn't have a fixed melting point. It melts in a range of temperature. What do you mean by range of temperature? At first it starts becoming soft, and this softening process is continued and ultimately it melts. Okay, that means it melts within a temperature zone. Okay, now coming to cleavage properties. What is cleavage properties? When crystalline solid is cut by a sharp edge tool, then they have a smooth and plain surface. Okay, why this is so? Because crystalline solid have regular pattern. Okay, whereas when we cut amorphous solid, then the resulting piece will have rough surface. Okay, now coming to heat of fusion. What is heat of fusion? At first let us understand what is heat of fusion. Heat of fusion means it is the amount of heat required to convert 1 mole of solid into liquid form. Okay, crystalline solid have definite heat of fusion. That is, if 1 mole of crystalline solid is to be melted, then it will require definite amount of heat energy. Whereas in case of amorphous solid, 1 mole of amorphous solid will require variable amount of heat energy. That's why we can say amorphous solids don't have definite heat of fusion. Heat of fusion is also known as enthalpy of fusion. As I discussed earlier, enthalpy of fusion or heat of fusion means it is the amount of heat required to convert 1 mole of solid into liquid form. Okay, now let's move to another topic. Okay, next topic is anisotropic nature. Okay, this difference is very important, and in various exam anisotropic and isotropic were asked in previous time. Okay, crystalline solid are anisotropic in nature. Okay, what do you mean by anisotropic in nature? Let's first understand isotropic. Okay, then we will discuss anisotropic. Isotropic is made up of two words, iso and tropic. Iso means same and tropic means physical properties. Okay, what are the physical properties? Like resistivity, conductivity, refractive index, etc. Okay, in crystalline solid it is observed that when we measure the value of different physical properties in different direction, then we find they give different value. Okay, that's why we say crystalline solids are anisotropic in nature. Okay, whereas in case of amorphous solid, when we measured the value of different physical properties in different direction, what we get? We get almost same value. Okay, that's why we say amorphous solids are isotropic in nature. Okay, now let's move to next topic, nature. Okay, crystalline solids are also known as true solids. That is, they follow all the characteristic of solid. Okay, whereas in case of amorphous solid, they are called pseudo solid. What do you mean by pseudo solid? Pseudo means fake. Okay, that means amorphous solid don't follow all the characteristic of solids. Okay, let's give you an example. Okay, you are all familiar with glass of windows of old buildings are observed, then it is found that the glass at bottom is thicker than glass at the top. Why it is so? Because molecules of glass flows from top to bottom due to gravity. Okay, but we all know that solid should not show fluidity, but here glass is showing fluidity. That means glass is flowing. That's why it is known as pseudo solid. Okay, I think it became clear to you. Is it clear? Okay, now let's move to next topic. Okay, next topic is crystalline solid is of long range order. That means it follows a definite pattern over long range. Okay, whereas in case of amorphous solid, it may be regular at very short range. Okay, okay, now we will discuss classification of crystalline solid in next video. Okay, thanks for watching. If you have any doubt, write down in comment section. Okay, if you want to give me any suggestions, okay, write down in comment section. Okay, thanks for watching once again. Okay, thanks.